Okay, so in this problem we have a crate of mass m, which slides to the right on a rough surface with a kinetic coefficient of friction of mu k. In this problem we're asked to take this information and find the reactions at contact points A and B on the crate. Okay, so the way I'm going to work this out is I'm going to note that because we're looking for forces, it makes sense to start by drawing a free body diagram. And so if I draw my free body diagram here on the provided diagram, we can note that we'll have some weight mg acting down. We'll have some normal force here at B. We'll have some normal force here at A, which I can call NA. And we'll have, because we're moving to the left, moving to the right, we'll have friction forces acting to the left, which I'll call FA and FB respectively. So with this free body diagram in mind, I can then start by writing down my kinetics equations. So I'll say first of all the sum of forces in the x, assuming conventional xy axes, has to equal the mass of the crate times the acceleration of point G in the x. And if I work this out here, I'll have minus FB minus FA is going to equal m times the acceleration of the center of mass in the x. I can call this equation 1. I can also sum forces in the y direction here, noting that the center of mass of the block is not going to leave the surface. It's going to be 0 here. And so what we'll have is NB plus NA minus mg is going to equal 0. We can call this equation 2. I can also sum for moments here, and I'll do so about point G, and set that equal to 0 because we know the block's not going to rotate. I'll do this in a counterclockwise positive sense. And if I do this, I'm going to have, first of all, a positive moment created by NA. So I'm going to have NA times its moment arm, which will be B. I'll have a negative moment arm created by NB, so I'll have minus NB times B. And then I'll have negative moments created by FB and negative moment created by FA, respectively. And so I can set that equal to 0 and call that equation 3. Now if I look at these three equations, I currently have 1, 2, 3, 4, 5 unknowns. And so the way I'm going to get additional equations here is I'm going to note, because we have sliding friction, that FA is going to equal UK times NA. We can call that equation 4. And finally FB is going to equal mu K times NB, and we can call that equation 5. And so if you solve the system of 5 equations, 5 unknowns, you can solve for the reactions NA and NB as asked for in the problem, and adopt a straightforward algebraic approach to do so. I know you have the skills to handle that, so I'll simply at this point wish you the best of luck, and have a good evening. Take care.